All right. Today, I suppose before we start today, we're not going to do this every time, but we've only had 3 things so far, right? We've really only done 3 things. What did we do on day 1? Which means great, and then that leads right into day 2 with 2 words. And which one of those goes with which one of those 2 words from day 1?
Domain is input, range is output.
So it's kind of like we did the same thing, right? Both days. Domain, input, output, or function, outside. Input, output. You input time, you output the distance you ran. You input time, you input how many times you spun around. You input number of times you grabbed grass. You output number of blades you have. Domain, the inputs. Range, the outputs. And then the 3rd day was a little different. We took a little side track to do what? Oh, we start with slope or rate of change, average rate of change. Graphs, increasing, decreasing, maximum, minimum.
Absolute.
Local mins and maxes and absolute mins and maxes. That's true. I was just lumping all those together in mins and maxes. As you go through, you can look at both. Okay. And then graphing piecewise, which I get, it stinks. That's the worst thing. All right, so today, that's pretty much it. That's saying congratulations, you know functions, way to go. Now we're saying, hey, if you do have functions, you can do these 4 things to them. Technically 5 things, but we're going to start with these 4. If you have functions, you can do these 4 things. You can add them. You can subtract them. You can multiply them. You can divide them. And it's exactly what you would think it would be. You can add them. You can subtract them. You can multiply them. You can divide them. There's no trick. There's no sneaky thing. It is what it says it is. There's only one hiccup. I know you have your paper. Pretend like you don't. Don't look down. This would be the only hiccup right here. What's the hiccup that gets introduced, or the scary thing, or the bad thing? This thing, right? What about it? And that says it probably literally right next to it, doesn't it? Yeah. But, so you can do all the normal stuff, adding, subtracting, multiplying, dividing, just like you would, but it's only when you divide you get one little hiccup, and that's all that there is to that. You just have to, now we have to go to day 2 and do our domain thing, because we added divide. Everything else, pretty normal. Cool? Let's get going. We'll do it in colors and just see how we do. This is great. My pen broke first hour, so it was just awful. I couldn't write anything. I was writing with my finger the whole time, and I just cut it, and now it works again. So this is great. F times G. Okay, so this is another fun way to write F times G of X, right? Which is another fun way to write what from up above. I'm not going to scroll up. That's exactly what we're talking about. One function times another function. Cool? And so then, what is f of x? And what is g of x? Boom. Oh, shoot. There's a consideration to be done. I wish it was easy. I wish it was just straightforward. We have to do this special word. It is just like distribution. It's double distribution, if you want to think of it in that way. Some people learned it like at different schools or whatever, and they learned it just like the distributive property, but they'd call it double distribution, where you go like distribute, distribute, and then maybe in a different color, distribute, distribute. You end up with the same 4 terms as FOIL, first, outer, and last. So totally up to you how you want to do it. Term number 1. First, x cubed. Term number outside, minus x. Term number inside, term number last. And I might rewrite it just for the sake of the way we always see it. X cubed plus 1. If the X's look squiggly today, that's because my pen's a little broken. See how they get a little worse handwriting? Okay. Boop. 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 Not too bad. We foiled. I suppose I forgot to draw the last, but we wrote it out, we foiled, and we did the whole thing. It doesn't ask us for it, but just for fun. Don't look at the whole problem, just look at that answer, because that is the answer. What's the domain of that? How'd you know that? Fine, but also house. It said the end behavior, which is cool and good to know, and that means all real. That's what you're talking about? All real numbers, cool. But how else could you know it's all real numbers? Yeah, there's no domain restrictions. There's no bad numbers. There's only 2 things that can happen. What's one of them? There's only 2 bad domain things, 2 restrictions. Number over 0, square root. If those don't happen, all real numbers, right? I know it didn't ask for that, but just thought it'd be fun. Domain, all real numbers. Get the cell phone holder out. Did you hear that ding? Okay, let's hop over here and do the subtraction one. It says f minus g of x, right? Which is f of x minus g of x. Which is, heck if I remember, x minus 1 minus x squared minus 1. And here's the reason they gave us this FOIL and this one. If they gave us a plus 1, we wouldn't see this possible mistake. There's one possible mistake here that's pretty common. Yep, you have to remember to distribute that negative sign, right? So it turns into x minus 1 minus x squared. But then negative negative turns into a plus 1. So something really cool happens there. Minus 1 and plus 1 go away. And we are left with being out of room. X minus x squared. I don't know why the book asked, are they the same function? Are those 2 things the same function? No, I don't know. It just seems like a random question to me, but it was in there. I went and double checked this morning. Like, that seems like a random question to ask at the end. But no, multiplying and subtracting don't give you the exact same thing. Go figure. Oh, unless they were asking, are those... I don't actually know. No, I don't know. Cool. That is all that we're doing for those. Plussing, minus, subtracting, and adding. We'll have a lab where we do a lot more today. But that's it for that. Now we move on to the harder, funner stuff. Oh, it's a lot of words. Okay, I'm zoom into the definition. You can add, you can subtract, you can divide, you can multiply, or you can do this thing. Anybody seen the movie Inception? Yeah? You never seen it? It's a great movie with Leo and Joseph Gordon-Levitt, and I don't know who else. A lot of people, I think. Just can't remember. Oh, Cillian Murphy, freaking Peaky Blinders guy. Okay, it's a great movie. You should go watch homework. Everybody go watch that movie. I don't know where, but what's the concept of that movie then? Yeah, they're dreaming, and then inside of that dream, they're like, we're gonna go. Well, no, actually, they can first go into a dream, right? So they're like inputting themselves into someone's brain or dream, right? Bear with me. And then once they're inside of their dream or their brain, what can they do again? Go into like one of their dream person's brain streams. And then they even one time in the movie go a third one and they get to the snow place. Is there a knockoff episode of SpongeBob? There's probably tons of those types of things now. But that's what this is. This little O right there that looks like an O or a dot is actually an of. Yep. Thank you. And saying, hey, X is technically my input. What am I inputting X into?
G.
And then what am I inputting that answer into? And then you can input that answer into an H if you wanted to, right? And you can keep going forever and ever and ever. It's a function. Well, actually, on the most inside, it's an input. The guy had to jump into the first string. Input. It's an input inside of a function inside of a function. It is not multiplication. It's not combination. It is doing the function step a bunch of times. Doing the input-output step a bunch of times and repeating it. Cool. So they give us this really great example, which is actually a pretty common world example. We're going to skip all the reading and stuff because it's just a lot. Gravity has a force. Gravity weighs you down, right? And that's kind of what the first thing is saying, is that there is a force of gravity, and you know what it's based on? That the force of gravity is based on? Just guess. Distance from the sun. Or our distance from the earth. Or your distance from the center of whatever mass you're gravitating towards, right? So that's what the R is. I think R is radius. It doesn't say it on here. It says distance from the sun, but R is standing for radius because, you know, you're on your orbit. You're always an R away. So it's saying there's a force that's based on your distance. Or force, you input a distance, you input a radius, you output a force. But then, if you have a force, Newton's second law, Newton's third law, Newton's first law.
What are you trying to say?
You know what I'm talking about? Force equals mass times acceleration.
Oh, wait, no, that's not.
That's Newton's. The third law is equal and opposite.
No, the second law is equal and opposite.
No, the third law is equal and opposite. Somebody Google this. Somebody Google Newton's three laws real quick. I think it's 2 is F equal ma. 1 is an object at rest tends to stay at rest. An object in motion stays in motion, right? 2 is that mass and force are proportional. Yes? Doesn't matter. But, okay. Newton's third law says that force, if you have a force, then you have an acceleration. So there's an acceleration that's based on a force. Right? So we're going to call that A. So now we got A is equal to little a of capital F. Now where's the inception happen? Or where's the dream within a dream happen based on those two things? There's an inception that needs to happen now. This green thing, right, goes right into there. And we're left with equals little a of g of r. So your total acceleration is based on radius, actually. Because your gravity force is based on radius. It's kind of not very practical. I know that's a lot of weird stuff. Just saying that your acceleration is based on gravity force, and gravity force is based on distance, and therefore your acceleration is based on distance. If you drop something on the moon, it doesn't accelerate as fast, is what that's saying. You go to the moon, you drop this pin, it falls really slow. But it works out a lot nicer and neater than that. Use the table below to find these things. First things first, can you find g of 1? Yeah, can you find g of 1? Bless you, bless you. G of 1 is 3. So technically, the question isn't asking us f of g of 1. Technically, the question is asking us what? Hey, that makes our lives a little easier, right? And can you find f of 3? Oh, I'll do it in a different color. Watch this. 3, and there's your answer. You did 2 function steps. You did not add. You did not subtract. You did not multiply. You did not combine. You did the function step twice. You looked at the table twice, right? Typo. There's a typo. Fix it. Oh, did you try to do it and couldn't get it? Oh. What? Because there's a type. This is a typo on your paper, not on mine. Fix your paper, not. Well, you could try to do your paper, but I messed up when I was typing it this morning, and I changed it last minute. This is correct. I'll do different colors. Do you know f of 4? What is it? So technically, they're asking us for g of 1. And do you know g of 1? I'll do it in the last color I have. G of 1. Oh, it's the same thing? Cool. And there's some shapes there to help out. That's not bad, huh? That's easier than the acceleration gravity force distance thing that we had as an example. If you want to try to do the typo on your paper, you'd probably see something real quick. It doesn't have a second spot to go to, right? We would need more information. That was me just messing up. All right. Do the exact same thing, but with the table. So can you find? Actually, I'm not going to ask a question. Thoughts on what we could do first?
You look at the f of x graph, and then you see 2, and then you go to 5, and then you go to the other.
Okay, well, hold on. So you said look at f of x.
Yeah.
Now what?
You go to 2.
Because of that inside?
Yeah.
So we're really looking for g of
2.
whatever this spot is right here.
Yeah, 5.
And then, shoo-ba-doo-ba-doo. Oh, is that the third one that's 3 in a row?
Yeah.
What do you think the next one's going to be?
7. You go again.
Oh, is it?
No, I don't know. I didn't.
That would be really fun if it was. So, hang on. I want to make sure. So this 5 we got from here, right? And this 3 we got from here. We did not multiply. This is the hardest thing because it'll happen. You'll get stuck and you'll forget on a test or something, and you'll go to multiply or you'll go to divide or subtract. We didn't do any math. We did the input-output step of a function twice. That's what's so scary to me is like the reason we did these abstract functions on day 1 with like number of spins or blades of grass or number of trials is because sometimes the function is just looking and writing and not doing any adding, subtracting, multiplying, or dividing. Both of those steps had no math, or what we should call arithmetic. They had no third grade math in them. They only had input, output, do it again, input, output. There was no arithmetic to be done, no adding or multiplying or squaring or foiling or factoring. Just looking and input, output, input, output. Now this next one ropes back into math, I think. But it's actually not that bad of math. Because again, I don't know. It's our first step, first thought that we should do. It's been the first thought every single time. It where though? Oh, there's only one. Dang it. Sometimes it'll say XX, and that makes it harder. But we're going to look at F, right? And we're going to say, what is actually F of 2?
2 squared.
That looks like F of Z. It's 2 squared,
Minus 2.
which is 4 minus 2.
2.
Cool.
And then you plug that in.
H of 2 equals.
3 times 2.
Honestly, I think that's the heater that just kicked back on. Because this is this big tube right here is an empty, hollow air conditioning pipe, I think, or something. I don't know. Or maybe it's just up there. I don't know. That's probably what that is, though. 8? I'm not going to do it right now, but I think it's really worth talking about. Could you have? There's a different thing we could have done. We could have done it a completely different way that you're allowed to do. You know what we could have done? See that red cloud right there? Where could that red cloud go to? Because we're taking F and we're incepting it or putting it inside of a dream. We're taking F and putting it inside of H, right? So where could it go to? Right there. And you could go 3t squared minus t plus 2, right? And then probably distribute a property that thing. And you end up with, I said I wasn't going to do it, but I'm doing it anyways. 3t plus 2. And then you know what we're plugging into t? 2. And you end up with 3 times 2 squared plus, nope, minus 3 times 2 plus 2, which is 12 minus 6 plus 2, which is, you don't have to do that. I'm saying, you could have gone function first, and then plug and chug. Allowed. Though every single time, it's always harder. I've never seen it be an easier step. It's always easier and more practical for you to do. Plug into the first inside function, take that answer, plug into the outside function. All right, I might give you a minute or two to try this -2 one, because we're almost done. I will be done a little early. Yeah, I'll let you work on this for 1 minute or two. Go, go, go. Oh. It is the AC rattling the board. I don't know what to do about that.
I thought it was the projector. That's why I asked.
The projector?
I thought it was that.
Oh, no. It's definitely like a fan or something. Sounds like it's this chalkboard. You're not doing it? You already did it? Oh, you just did it while I was talking about the other one? That's okay. I forgive you. Did anybody get f of -2? Anybody over here? Y'all are quiet. What is it? No, what is it? 20? And then you took that 20? Oh, well, you weren't listening to me, is what that means. Did anybody get f of -2? What was it? 6? And then you took that 6? And you went h of 6? And then when you plugged that in, you got? Oh, the 20 you were talking about earlier? Nah, that's fine. I didn't show any work there, but it sucks. All right. Last but not least. What? Wasn't that an answer? Oh, thank you. Is that better? All right, last but not least, there is this one ugly, annoying thing. Because we talked about domain and range above. We said the only bad, weird domain is dividing, right? Because you divide something. Well, this one has a weird domain. This one is a weird domain when you plug it into a function. And here, there's 3 steps that this is new if you were in my class last year and these notes look familiar. This is a new, try to make it easier. There's 3 things you have to do. Well, really, there's only 2 things you have to do. The third is just remember not to do something. So here's what you do. You check the inside function. Then you check the whole thing. But you don't check the outside alone. So you check. It says g of x and f of x, but it might be different, right? So I really wanted to give you that inside-outside. You check the inside, and you check the full thing, but you don't check just the outside function. So for example, from above, I would check f of x. I would check h of f of x, but you know what I wouldn't check? H of x by itself, or t or whatever letter they give you. You don't have to check h of x. That's not in there. So it's really 2 steps. And then remembering, don't worry about the outside by itself. You do have to worry about the outside with the new stuff, though. So what does that look like? Well, here we go. I suppose we could start by just doing it and not checking domain. I know it says find the domain, but we're going to have to do it anyway, so let's just do it. What is f of g of x? 1 over. Okay, hang on. Before you say that, I'm going to put a big box right there. I'm going to pause. For someone not, you're right, go roll, go do the whole thing. Why is that box there? What did it take the spot of? And x is just a variable. So it's just to put something here. Not even a number now. It's not a value anymore. Now it's a put anything here, even including a function. Put another function. Put 2 functions inside of the function. So what's going actually inside of that variable spot? Oh, I should make it red. So this is our red function for this problem. And this is our blue function. Root x plus 4. I brought colors today for our lab, so you could do this if you want to. Because I think it's just so much easier to see when you can have the layers or the dreams all in different colors. Okay. So that is your function. But we have to do the domain because it asks us to. So we have to check first the domain of the inside function, which is this g of x. Isn't g of x inside this time? Yep. So this is the inside. And because you all went home this weekend and studied last week's stuff and you're masters of domain now, you can say it without even thinking. Oh, crap. So we're not masters and we're not great. So we're going to go ahead and say there's 2 things that could happen, right? What are the 2 things? Number over 0 or radical. Which one's this one? So we don't even need that right now, right? We will later. And with the radical, we say the inside, this is the step that we're forgetting or not remembering. This is the big step. This is the important step, is to know what's in this box right here. The inside has to be what? Greater, not equal. Greater than or equal to 0. You said that already? Oh, tough. So x plus 4. That's the jump to. That's where we want to jump really fast and be able to do. Which means that x is technically bigger than or equal to negative 4. And in interval form, that looks like negative 4 ad infinitum. We checked the inside. Yay. Now what do we need to do? We check the inside. Check the whole thing. Okay, let's check the whole thing. Are there any possible bad numbers for the whole thing? The denominator better not be. So we're going to go root. I need more room. The denominator better not be 0. Root x plus 4 minus 2 better not be 0. Right? Which means the root of x plus 4 better not be 2. Which means x plus 4 better not be 4. Because that one's the weird one because we squared both sides, right? And then x better not be 0. Interesting. Now we really do have to point something out here as well. And that is there another bad number in the blue function, in the total function? Is there something else that can make the blue function bad? Don't even look at the red. Is there something else that can make the blue function bad? Would 4 make it bad? 4 plus 4 is 8. Square root of 8 minus 2. That feels okay. I'm looking at not at this work we just did. That's just the work to find it. I'm looking at the blue total function. And we said the bottom better not be 0, right? And then we solved that. Is there another thing that could make this total function, which if you remember is f of g of x, bad? Start plugging in numbers and seeing if you find a bad one. We know 0 is bad, right? 0 is totally bad. Look. 0 plus 4 is 4 rooted 2 minus 2, 2. Bad. Is there another bad number or a domain restriction? Negative 2? Negative 2 plus 4 is 2. Rooted is root 2. It's fine. I don't know what it is, but it's fine. Minus 2 is a number. No, it's fine. Anything less than negative 4? What about negative 100? Do negative 100. Negative 100 plus 4 is negative 96. Root that. Can't. So there's this same, now, you would have been fine if you didn't catch this, but it's the exact same boundary as the other one. Because it's the exact same function. It's got that exact same boundary coming out of it from there. What? You are super right. So now we need to mash those two things together somehow. We need to mash both of those answers into one full answer. The easiest way to mash them together is on a number line. And there's only 2 key points. We've got negative 4 and we've got 0. What's happening on this number line? Open circle there for sure, right? Closed circle, shade. So it looks kind of like that. Or you might see it like this in the book. They mean the same thing. And to finish this long problem off in interval notation, what's that interval look like? Comma. We got to stop at 0. We got to say, don't include me. Unite it. Don't include me again, but go on forever after me. That is, last but not least, finally something that we can report to the question asker. What's up? Sure. Unless it's said on the question in interval form. You could also do set notation. Here's what's interesting though. If you just look at the blue function by itself, reel back in. If you missed all that, reel back in. If you just look at the blue function by itself, what's probably bad number? 2, right? Now go back over to our answer. Is 2 in the domain? Is 2 allowed to be plugged in? Well, let's look at our function. Is 2 allowed to be plugged in? 2 plus 4 is 6. Can you root 6? I can't, but it's allowed. It's not negative. Minus 2, number. 1, number. And that is the third thing. Don't check. Don't check the blue thing. Don't check the outside one by itself, because it'll throw you off. You check the inside one, and you check the full thing, but you don't check the blue one because it'll throw you off. Don't worry, we're going to practice this all lab. We're not doing anything new in lab. We're just going to practice what we're doing today. Last but not least, I'm going to let you do this because there's so many possible answers. That'll give you 5 minutes, and then we'll report back, and then you get a 20-minute break. So, f of x. F of x is what you see, right? It's this long function. But you could also write f of x as g of h of x. And I'm asking you to find those two functions. There are literally 20 possible answers, so you might have something different than your neighbor. What is g of x? And what could h of x be? And I will open this up so we can report like a bunch of answers. Cool. You can talk to your neighbor, see what they're thinking. But what I'm saying is, you can break that up into two different functions, an outside and an inside. What could be an outside function, and what could be an inside function? What? Well, give us 30 seconds. And then... we'll do our lab. All right, let's get a thought. Kiki, you had the first one. I'll let you go. What's your outside function? 4 over 3 minus x. Don't answer the next one. Somebody else finish your inside function. What would the inside function be?
Okay.
Oh, you have the same exact outside function?
Huh?
You have the same outside function?
No.
Oh, no. I'm saying somebody else that didn't do it. What would an inside function be to complete if you look up at the very, very top? Root of 4 plus x squared. If you take that and you plug it into the x above, do you get the total thing? Cool. All right, let's get a different answer. Somebody else have a different outside function or a different blue function? This is our total up there in the red. Up here. That's our total function.
Yeah, I think mine is wrong, but I can tell you that.
No, let's hear it. Well, even if yours is wrong, if you give us the first function, we can give you the right second function. So what's your outside? Yeah, you have to.
Oh, 4.
Over? 3? That's it straight up?
Yeah.
Well, then we have nowhere to plug anything in.
I know, that's what I told you.
Oh, yeah. Okay, give me the inside function. Give me the inside function. I changed my mind. Do you have an inside function we can try?
It's 4 plus x squared.
Oh, we can work with that. Okay, let's work backwards. Somebody else.
No, so
You know it now?
Yeah.
All right,
Is it
fine.
Negative x and a radical or no?
You're saying 4? Oh, you're saying that was from what you had a second ago? Like that? If you plug the red into the blue, does it work? Indeed. All right, let's get another one. Let's get another one. Let's get another one. Anybody do anything different? What? There's so many. Nobody did like the easiest one? That's what I did. That's what I would have done. Actually, and I learned it's actually not the easiest, but 4 over x, which means what's got to go into that x? The whole bottom? Somebody last class said, yeah, but this one's easier. Watch this. No, the red is x squared. The insidest function is x squared. So what is everything else? 4 over 3 minus root 4 plus x. And now all you do is take that red and plug it into the x and you got your function.